Hi, this is javinkharod, chemical engineer by profession, going to continue our today's topic, refining of petroleum. Now, petroleum is a complex mixture of organic liquid called crude oil and natural gas, which occurs naturally ground on land and under the ocean by sinking an oil well, and they are transported by pipeline and ship refinery where their components are proceed in the refined net product. Crude oil and natural gas are of little use of raw waste, and it is value lies what is created the fuel, lubricating oil, wax, asphalt, petrochemical, pipeline, quality natural gas. Oil refinery is organized, coordinate, arrangement, manufacturing process designed to produce physical and chemical changes crude oil to convert everyday product like petrol, diesel, lubricating oil, fuel oil and bitumen. Now crude oil comes from the well. It contains mixture of hydrocarbon compound and relative small quantity of the material oxygen, nitrogen, sulfur, salt and water. They are refinery. Most of the non-hydrocarbon substances are removed, oil broken down into various components and blended into useful product. Natural gas from the well and principal methane contain quantity of other hydrocarbon, ethane, propane, butane, pentane, also carbon dioxide and water. These components are separated methane as gas fractionation plant. Now, paraffin. This consists straight chain of branch carbon ring saturated with hydrogen atom, the simplest of methane. Main ingredients are natural gas. Other in the group include ethane and propane, hydrocarbon. With very few hydrocarbon atoms, C1 to C4, light are density. They are gases under normal atmospheric pressure. Chemical, paraffin are very stable compound. Naphthene. Naphthene consists carbon ring, something and sometime when side chain saturated with hydrogen atom. Naphthene are chemically stable. They occur naturally, crude oil, and have properties similar to paraffin. Aromatic. Aromatic hydrocarbons are compound contain ring of 6 carbon atom with alert, double and single bond. 6 attached with hydrogen atom. This type of structure, benzene ring, they naturally occur crude oil and can also create a refining process. More carbon atom, hydrocarbon molecule has heavier, higher molecular weight, higher is boiling point. Small quantity crude oil, compound contain oxygen, nitrogen, sulfur and metal. Sulfur content range is more than 5%. If crude oil contain appreciable quantity sulfur, sour crude, it contain little or no sulfur or sweet crude. Refining process. The fraction are further treated to convert them mixture more useful, safe product. Various methods such as cracking, reforming, alkylation, polymerization, isomerization, mixture, new compound are then separated using methods such fractionation and solvent extraction impurity are removed. Various methods dehydrogenation, desalting, sulfur removal and hydrotreating. Refinery process have developed response changing market demand for certain product. With the advent of internal combustion engine, main task of refinery become production of petrol. Quantity petrol available for distillation alone were insufficient to justify customer demand, breaking down large heavy hydrocarbon molecule, reshaping, rebuilding of hydrocarbon molecule. Now, distillation. Because crude oil is a mixture of hydrocarbon, different boiling temperature, it can separate distillation into product and group hydrocarbon that boil between two specified boiling point. Two types of distillation are performed, atmospheric and vacuum. Now atmospheric take place distillation column near atmospheric pressure. Crude oil is heated 350 to 400 degrees centigrade. Vapor and liquid are piped into distillation column. Liquid fall bottom and vapor rises passing series of perforated tray. Series tray, heavier hydrocarbon condense more quickly and settle lower tray. Higher hydrocarbon remain vapor longer condense on higher tray. Liquid fraction are drawn, tray and removed. The way light gases, methane, ethane, propane, butane pass out top of the column. Petrol is formed top tray. kerosene and gas oil in middle and fuel oil bottom. Residue bottom may burn fuel, processed lubricating oil, wax, bitumen, use fish stock for cracking unit. Recover additional heavy distillate residue, it may pipe the second distillation column where process is separated under vacuum called vacuum distillation. This allows heavy hydrocarbon with boiling point 450 degrees centigrade higher separated without partly cracking into unwanted products such as coke and gas. Heavy distilled recovered vacuum distillation can convert lubricating oil by variety of process. Most common called solvent extraction. The version the process heavy distilled is was liquid which does not dissolve and so extracted non-lubricating oil compound. Another version use liquid which does not dissolve but causes non-lubricating oil component precipitate from it. Other process excess removal impurity, adsorption, highly porous solid, waxes present causing them to crystallize and precipitate out. Now reforming. Reforming is a process, heat, pressure and catalyst contain platinum which about chemical reaction upgrade naphthene into high octane petrochemical feedstock. The naphtha or hydrocarbon mixture contain many paraffin and naphthene overseas into come thermal cracking, hydrocracking process, reforming convert portion. This compound, isoparaffin and aromatic, they are used blend higher octane petrol. Paraffin are converted isoparaffin, paraffin are converted naphthene, and naphthene are converted to aromatic. Now cracking. Cracking process break down heavier hydrocarbon molecule, high boiling point to lighter product, petrol and diesel. The process include catalytic cracking, thermal cracking and hydrocracking. Catalytic cracking convert heavy hydrocarbon fraction, obtain vacuum distillation, mixture more useful products such as petrol, light, fuel oil. Their feedstock undergo chemical breakdown under a controlled heat and pressure. The presence catalyst, a substance, promote a reaction with itself being chemically changed. Small pellet of silica alumina, silica magnesia have proved the most effective catalyst. The cracking reaction yield petrol, LPG, unsaturated olefin compound, crack into oil gas, liquefied residue called cycle oil, light gases and solid coke residue. Cycle oil are recycled, causes further breakdown, coke and form layer on catalyst. The burning other product pass through fractionator, separated separately process. Fluid catalytic cracking are catalysts form of very fine powder which flow liquid when agitated steam, air, vapor, feedstock entering the process immediately stream very hot catalyst and vaporize the resulting vapor. Keep catalyst fluidize into passes or reactor where the cracking takes place, where it is fluidized hydrocarbon vapor. The catalyst next pass steam stripping section. Most of volatile hydrocarbon are removed, then pass regenerator vessel where it is fluidized. Mixture of air and product combustion product such as coke on catalyst burn on and catalyst flow back to the reactor. The catalyst undergo continuous recirculation between reactor stripper regenerator section. Catalyst usually mixture of aluminum oxide and silica. Most recently, the introduction synthetic zeolite catalyst allow much shorter reaction time and improve yield, octane number, crack gas oil. Thermal cracking, break down residue, vacuum distillation, light element proceed. They are introduced different fuel, petrol, diesel and crack gases. They are converted petroleum blending component by alkylation, polymerization, naphtha upgraded high quality petrol by reforming gas oil can be used, diesel fuel can converted petrol by hydrocracking. Heavy residue, converted residue oil and coke which is used manufacture electrode, graphite and carbide. Hydrocracking increases yield, petrol component well being used, produce light distillate, it is produced no residue, light oil. Hydrocracking, catalyst cracking is presence hydrogen, extra hydrogen saturate or hydrogenated. The chemical bond, crack hydrocarbon, create isomer with desired characteristic. Hydrocracking treating process because hydrogen combined with contaminant such as sulfur, nitrogen allowed them to remove gas oil fluid mixed with hydrogen, heated sand, reactor vessel with fixed bed catalyst where cracking and hydrogenation take place. Products are sent fractionator to separate the hydrogen recycled residue from the reaction, again with hydrogen, retreated, sent to second reactor for further cracking under higher temperature and pressure. In addition, naphtha making petrol, hydrocracking, light gases, fuel oil refinery, alkylation, well component high quantity fuel oil, lube oil and petrochemical feedstock. Now cracking process are built, rearrange some of the lighter hydrocarbon molecule, petrol, jet fuel, blending component, petrochemical, FOMO can achieve several chemical process, alkylation and isomerization. Now olefin, polypropylene and butylene are produced catalytic thermal cracking, alkylation refer the chemical bonding, light molecule, isobutane and large branch chain molecule that make higher octane petrol. Olefin and isobutane are mixed acid catalysts, cooled. They react from alkyl. They are normal butane, isobutane and propane. They are resulting liquid neutralized, separate series of distillation column. Isobutane is recycled feed and butane, propane, solid liquid petroleum gas. Now isomerization refer chemical rearrangement, straight chain hydrocarbon and long chain branches attach, main chain isoparaffin. This is done for two reasons. It creates extra isobutane from the alkylation. It improves octane, straight run pentane, hexane and hence can make better petrol blending component. Isomerization is achieved mixing normal butane, little hydrogen and chloride. They are allowed at react presence catalyst to isobutane plus small amount of normal butane. Some of lighter gases products are separate in a fractionator. Lighter gases are used refinery fuel. Butane recycled as feed. Pentane and hexane are lighter component. Petrol isomerization can use improve petrol quantity converted hydrocarbon higher octane isomer. Process same butane isomerization under pressure and temperature over acidic catalyst. Light unsaturated hydrocarbon molecule react and combine each other form larger hydrocarbon molecule. Such process use react butane, olefin molecule, carbon atom, isobutane, branch paraffin molecule, isoparaffin with 4 carbon atom obtain high octane olefinic petrol blending component called polymer gas oil. Now, number of content and contaminant are found in crude oil as fractionation travel to refinery process unit. Impurity can damage equipment, catalyst and quality of product. They are also legally contain some of impurity, sulfur in product, hydrotreating, one-way remove, many contaminant, many of the intermediate final product, hydrotreating process, entering feedstock, mixed hydrogen, heated 300 to 380 degrees centigrade, oil combined with the hydrogen and enter reactor loaded with catalyst promote several reactions. Hydrogen combined with sulfur to form hydrogen sulfide. Nitrogen compound are converted ammonia. Any metal contained in an oil are deposit catalysts. Some of the olefin, paraffin, and some cracking take place, causing the creation some methane, ethane, propane, and butane. The hydrogen sulfide create hydrotreating, toxic gas, need further treatment. The usual process involves two steps: the removal hydrogen sulfide gas, hydrocarbon stream, and conversion of hydrogen sulfide element, sulfur non-toxic and useful chemical. Solvent extraction using solution dimethyl amine dissolved in water. This is applied. Separate the hydrogen sulfide gas and process stream. The hydrocarbon gas stream contain hydrogen sulfide is bubbled through a solution diethylamine solution, higher pressure. Such the hydrogen sulfide gas dissolved in a hydrogen mixture and heated lower pressure, dissolved hydrogen sulfide is released as a concentrate gas stream, sent another plant. The conversion into sulfur. In conversion, concentrated hydraulic sulfide gas into sulfur occur 2 stages. Refinery, the environment, air, water and land affected refinery operation. Refinery are well aware responsibility. Community employ variety process to safeguard environment. Air. Preserving air quality around a refinery involves controlling following sulfur oxide, hydrocarbon vapor, smoke and smell. Sulfur enter refinery crude oil. Feed many products use refinery product hydrocarbon vapor, escape vapor. The atmosphere prevents various means. Floating roofs are installed to prevent evaporation so that no space for the tank are collected in a vapor recovery system to absorb back into product stream. The addition pump and valve are routinely checked. Amazon repair. Leakage is found. Smoke is informed when burning mixture contain insufficient oxygen, not sufficient mix. Modern furnace control system. This happening during normal operation. Smell are most difficult. Amazon control. The easiest to detect. Refinery and generally associated compound contain sulfur, where even losses are sufficient causes noticeable odor. Water. Aqueous effluent, cooling water surface, water process water. The majority of water discharge refinery has been used cooling the various process streams. Cooling water does not actually come into contact with the process material and very little contamination. Cooling water pass through large interceptor which separate oil from minute leak, etc. Prior discharge, the cooling water system once through system no circulation. Rainwater falling refinery site must treated before discharge. Ensure no oily material washed or process equipment leaves and refinery. This is done first passing through the smaller plant oil catcher and small stream passes a large inceptor similar to those. They use cooling water, rainwater from the production area further treated dissolved at flotation means DAF unit. This unit clean the water using fluctuation agent and collect many refinery particles, oil droplet, floating resulting flock and surface, million of tiny air bubbles as the surface. Flock is skimmed and clean water dissolved. Process water has actually come in contact with process stream, so contains significant contamination. The water treated in sour water treated and contamination, mostly ammonia, hydrogen sulfide, are removed and recovered destroyed downstream plant. The process water then treated where it is resulted part of refinery and discharged through process. Rainwater treatment system DAF unit. Any treated process water not reuse, discharge, trade waste and sewage system. Trade waste include from the refinery, sewage plant and portion of treated water DAF units. Now land. Refinery safeguard. Land environment. Appreciable disposal of all waste. With refinery, all hydrocarbon waste are recycled through refinery slope system. System consists network and collected pipe. Series of dewatering tank. Recovered hydrocarbon reprocessed through the distillation unit. Waste that cannot be reprocessed, either recycled, manufactured. Some of the spent catalysts. Dissolved. Environment Protection Act approved facility off-site, chemically treated on-site. The inert material which can be disposed landfill with the refinery. Waste movement within the refinery require process liquid, sludge and solid waste disposal permit. Waste that go off-site and Environment Protection Act waste transport permit. Okay guys, this is up to our today's topic, petroleum refining. I hope you get sufficient knowledge after watching this video. Next Sunday we have covered some another chemical engineering topics. Till then, goodbye. Do take good care of yourself.